Hello again. Let's now try some examples where we have to factor polynomials using everything that we've learnt so far in this series. We're also going to solve an equation at the end. Let's check it out. Factoring this, what we have here is a new technique. And whenever you see two sets of brackets like this, I want you to think of this question like this: 4x, and instead of x minus 3, why don't I just make apple, plus 5 apple. Right, because these are the same, aren't they? We've got x minus 3, x minus 3. If I'm going to factor this, what's common to both? Can you see that I can take out an apple, and I'm going to get this, apple. Apple times what gives 4x apple? That will be 4x. Apple times what gives 5 apple? That will be just plus 5. Does that make sense? We just take out the greatest common monomial factor. What if I told you that apple is x minus 3? What would that look like? Well, we're going to take out this x minus 3 here at the front. X minus 3 is going to get factored out. And what is left is another bracket. So anyway, we took out the apple. What was left over? We had 4x plus 5. And where did the 4x plus 5 end up? They ended up in a bracket by themselves. And that's what's going to happen here. 4x plus 5 ends up in its own little bracket down here. 4x plus 5. Like so. Okay, so we end up with two binomials multiplied together. And that is actually the final answer right there. Okay, so this factors to x minus 3 times 4x plus 5. And this method is called factor by grouping. Okay, just write that down somewhere. It's called factor by grouping, or factoring by grouping, or factorizing by grouping. And it basically happens every time. If I was going to expand that out, like do the distributive property here, I would end up with 4 terms, right? 4 terms. Whenever you see 4 terms and the question says factor the polynomial, you're going to use this. Let's try one where you don't already have those brackets there to start with. You've got to figure it out by yourself. B, so using that factoring by grouping, we need a step in the middle here. So what we do is this. We look at these first 2 terms here. Look at those 2. What I'm going to do is take out a common factor there. Just the greatest common monomial factor here, plus. And you can pause me at any time and work ahead and try and figure out what this is. We look at the first 2, what can we factor out of these first 2 terms here? And same here with the second 2. If I've got 8x plus 16, what can I factor out of here, like 8x and 16, a common factor? What could I factor out? Okay, go ahead and try and do the next step. Just pause me and try it. Hopefully you got it right. Here we can take out, so we've got x cubed and 2x squared. We've got x, so x is common. This is 3x's here, we've got 2x's here, so there's actually 2x's common to both. We can factor out x squared. And what else goes inside the brackets? Let's think backwards. This times what gives this? X. This times what gives this? 2. And over here, got 8x, 16. No x's are common, but we can take, they're both even, we can take out 2. Oh, wait a second, we can take out 4. Oh no, we can actually take out a full 8 here. And let's work backwards here. 8 times what gives 8x? X. 8 times what gives 16? 2. And now this should look familiar. This should look like part A. All right, we've got the x minus 2, sorry, the x plus 2 in both brackets. These have to be exactly the same. If they are not exactly the same, then factor by grouping does not work. And this will factor to what? I want you to do it. What's going to be the answer to that if you do factoring by grouping? C, 3x cubed minus 21x squared minus 54x. What do you notice here? We've only got 3 terms, so this is not a factor by grouping question. When you have 4 terms, you automatically think, oh, this is going to be factor by grouping. But we have 3 terms here, so that's not going to be the case. What are we going to do here? All it says is factor this polynomial completely. So the first thing you should always look for is a common factor. And what have we got here? 3, 21, 54. These three numbers are divisible by 3, I know that. There's a little trick here. If you add the digits, 2 plus 1 is 3. 3 is divisible by 3, yes. You just add the digits of the number, and that's a trick for divisibility by 3. 5 plus 4 is 9. 9 is divisible by 3. So 54 is going to be divisible by 3. It's a little trick. So we're just going to take out a common factor here. I can take out 3. Anything else? There's x's everywhere. So I've got 3 x's here, 2 x's here, 1 x here. So we can take out 1x. Now let's think backwards. What's going to go in place here? So I've got minus, minus. Go ahead, try and do this before me, okay? Take a little initiative. Don't just sit there, copy the answer. What do you think that's going to be? Pause, try it. What did you get? Let's think backwards. 3x times what gives 3x cubed? X squared. 3x times what gives 21x squared? Well, 7 3s are 21. X times x is x squared. 3x times what gives 54x? What's 54 divided by 3? 3 into 5 goes once, remainder 2. 3 8s are 24. 18. Minus 18. So 3 times 18 is 54. Sorry, I didn't have much sleep lately. I just want to check that. 18 times 3. 3 is 24. Yeah, sorry. And we're done. Or are we? Can this factor further? I want to emphasize this word here. Completely. Can this factor anymore? Yes, it can. 3x. Here we have a trinomial. Can this be factored? And here we go. We're going back to lesson 9.5. What we're looking for here are two factors. What we need are two numbers that multiply to give 18. I can't remember the colors I used. Was it? I think I did. Yeah, I think I did. Sorry, I did green first here, didn't I? I need two numbers that add to give minus 7. And I need two numbers that multiply to give negative 18. Remember, they have to be the same two numbers. These two have to be the same, and these two have to be the same. What are they? And you can actually use the cross method here if you like as well. But when we have a coefficient of 1, you can just think like this. So it's obviously going to be 9 and 2, right? Okay, 9, 2, 9, 2, but we've got negatives to worry about. They multiply to give a negative, which means one's positive, one's negative. They add to become a negative, so the larger size number should be the negative one, minus, minus. Let's check. That times that equals that? Yes. That plus that equals that? Yes, we've got it. So when this is completely factored or fully factored, it should look like x minus 9 times x plus 2. The x plus 2 could go here and the x minus 9 could go here. The order does not matter, but the correct answer is this. If you did this in a test, it's probably worth 2 points. 1 point for here, full marks for getting this right here. Okay, so that is how we factor completely. So what are these? If we're asked to factor these, what could we say these are? Well, we've got a trinomial. We don't even have a name for that. That's a binomial. So we can just call these polynomials. That is as specific as we can get. This one, how do we factor this one from last time? We've got 1, 2, 3, 4 terms. So we're going to use factor by grouping. But what's the problem here? Remember our first lesson on polynomials? How do we write polynomials in like a standard way? We always write the exponents getting smaller and smaller. So let's do that first. X cubed, 2x squared. Oops. Minus 9x minus 18. That's better. Remember what we said for our leading coefficient and degree? Remember what that was? What's the leading coefficient and degree of this polynomial now? The degree is 3 and the leading coefficient is 1. Okay, that might come up in the chapter test. Just a quick review there. Factoring this, let's factor by grouping. We factor the first two things first. What's common here? I can take out an x squared. And then what goes inside x squared times what gives this? X. X squared times what gives this? 2. And what about these two? What can I take out? Well, they're both negative. I can take it a negative. I can take it a 3. Or I can take it a 9. 9 times what gives that? X. 9 times what gives 18? Plus 2. Be careful there. Minus 9 times plus 2 gives minus 18. Be careful there. And do we have the exact same thing in the brackets? Yes, we do. Okay, so this is going to factor to x plus 2 times x squared minus 9. Is that factored completely? No, it's not. We're not done yet. This can actually factor. Here we've got a squared minus b squared. We can use that last special product. Sorry, this is getting a bit squashed here. This is a squared minus b squared. This will factor to x plus a times x minus, x, a plus b times a minus b. That is a fully factored answer there. To get all the marks, if that were a test, you have to get this perfect answer at the end. The factors can be in different orders, but they all have to be there. Okay, so that's a pretty hard one. And that's what we mean by factoring completely. Very important word there. B, we've got a trinomial. Okay, well, we need two numbers that add to give negative 4. Two numbers plus two numbers. And two numbers that multiply to give negative 3. And these have to be the same, and these have to be the same. Okay, what times what equals 3? Oh, 3 and 1. Easy. 3, 1, 3, 1. That times that equals a negative, so one must be negative, one must be positive. Okay, negative 4. That works. Oh, that doesn't work. Okay, let's try something else. Maybe this must be negative. That times that equals that. That works. That plus that. That doesn't work either. This question, it cannot be factored. This can happen, okay, in a quiz or a test. Not all polynomials can be factored. It's just the way it is, so don't forget that. This one, so I only got a binomial here, so we can just take out a common factor. What's common to both here? 8, 24, we can take out an 8. Oh, and we can take out a y. 8y times what gives 8y cubed? Well, that would be y squared. 8y times what gives 24? 8 times 3, 8 to 24, 3. Anything else? No, for C, that's it. Okay, just a simple greatest common monomial factor. That's it. And D. Oh, look, okay, this is going to be a factor by grouping. But are these exactly the same? No, they are not. We have a problem here. We have another trick we can do here. What I want to do is explain this. I'm just going to erase this here for a second. Or permanently. I'm not going to write it back up. Let me show you a little trick here. If I've got P minus Q, and I'm going to multiply by minus 1. What will that be if I get rid of the brackets and just do the distributive property? Minus 1 times P is going to be minus P. Minus 1 times minus Q is going to be plus Q. And it looks nicer if we write this the other way around. Q minus P. So look at that. Q minus P, and you can remove this 1 here. And let's see if I write it like this. Minus P minus Q equals Q minus P. Just kind of remember that like a silly little rule here. Okay, if you've got something minus something in brackets, if you put a minus outside, you can flip it around. So what I'm going to do here, here's the trick. Remember, I want the same thing in the brackets here. 2y squared times y minus 5. Here's the trick. I'm going to turn this minus into a plus. And then I can flip these two around. I can make this y minus 5. So remember that trick. You could do a minus to a plus or a plus to a minus, and you can flip those when there's a minus in the middle. And now look, we have y minus 5, y minus 5. And we can do the factoring by grouping. Let's do it. Y minus 5. And what's the other thing? So the y minus 5 goes there. And these two troublemakers here will go down here. Okay, 2y squared plus 3. Like so. And that is now completely factored. Okay, that is our answer. Solving this, so we've got solving an equation here. We don't have factoring an expression, we have solving an equation. So we're going to get that zero product property thing going here. We want it equal to 0. So let's take this 36x over there. 2x cubed minus 18x squared plus 36x equals 0. Remember, when something changes sign, it goes from minus to plus or plus to minus. Now let's factor. Can we factor this? Yes, we can. First thing we always try is to get a common factor, just a single greatest common monomial factor. Do we have anything? Yes, these are all even numbers, so we can take out a 2. And we also have x's everywhere, so we can take out an x. And what's left? Think backwards. 2x times what gives 2x cubed? X squared. 2x times what gives negative 18x? That's going to be minus 9x. 2x times what gives 36x? That's going to be 18. And there we go. So we've got something times something equals 0. Something times something equals 0. So this could be 0 or this could be 0. But wait, can this factor anymore? Yes, this can factor. So what I want you to do is 2x. Here we can factor this trinomial. What is it going to factor into? So what we're trying to do is look for two numbers that add to give negative 9 and two numbers that multiply to give positive 18. What do you think? Can you think of what those two numbers are? 6, 3, I think something to do with 6 and 3. And you know what? I'm not going to do the answer. I want you to figure this out. So we've got something times something times something. So here we've actually got, we're going to get 3 solutions. We're going to have this situation. Something times something equals 0, which means this could be 0. And I'm going to give you the first one. 2x equals 0. What's the solution to that? 2 times what equals 0? X must be 0. Or, and these two are going to, once you've factored that, they're going to give you 2 more solutions. So, wow, this has 3 solutions, or zeros or roots, okay? Can you write them all out for me and write your answers in the comments? X equals 0, and what are the other 2? Give that a try.